Okay, today we're looking at 3, the Ol Switcharoo, inverses of linear and quadratic functions. Okay, student works 1, 2, and 3. All right, let's take a look at the next page. All right, you can scratch out this page. All right, let's take a look at the next page. Activity 3.1, the inverse of a function. Miguel is planning a trip to Turkey. Before he leaves, he wants to exchange his money to the Turkish lira, the official currency of Turkey. The exchange rate at the time of the trip is 4 lira per US dollar. Complete the table of values to show the currency conversion of US dollars to Turkish lira. Write an equation to represent the number of lira. Well, first, let's complete the table. Okay, so we're going to go to Desmos, scientific calculator, and then we're going to do 100 times 4, 250 times 4, 400 times 4, 650 times 4, and 1000 times 4. Okay, so let's fill in our table. All right, so there's our table completed. Now we're going to use this table to find the equation. So I'm going to go to Desmos, graphing calculator, 3 bars, statistics, linear regression, open graph, and let's complete the table. Oh. All right, now we're going to zoom out to see if the points, you can see that the line goes to the points. The r squared is 1, so our equation is 4x plus 0. So y equals 4x plus 0, which is equivalent to y equals 4x. All right, let's take a look at the next. What are the independent and dependent quantities of the inverse of the problem situation? How do these quantities compare to the quantities in question 1? Okay, well, these switch. So the Turkish currency is 400, 1000, 1600, 2600, and 4000. And the US currency is 100, 250, 400, 650, and 1000. Okay, compare tables in question 1 and 4. What do you notice? The columns are reversed. Now, use a table to write an equation for the inverse. So to do that, we're going to come back over here. We're going to go here, statistics, linear regression, open graph, and then we're going to complete the table. So 400, 1000, 1600, 2600, and 4000. And then 100, 250, 400, 650, and 1,000. Okay, and we're going to zoom out. You see the line goes to the points. The r squared value is 1. So our equation is 0.25x plus 0. Which is equivalent to 1/4 x plus 0, which is equivalent to 1/4 x. All right, go ahead and finish that up. Let's take a look at the next page. Recall that a function takes an input value, performs some operation on this value, and creates an output value. The inverse of a function takes the output value, performs some operations on this value, and arrives back at the original function input value. In other words, an inverse of a function undoes the function. Work example. Given a function f of x, you can determine the inverse algebraically by following these steps. Replace the function f of x with another variable, generally y. Step 2, switch the x and y variables in the equation. Step 3, solve for y. Use function notation to represent the number of lira f of x in terms of the number of US dollars x. Then complete the steps shown in the worked example to represent the number of US dollars in terms of the number of lira. Compare the inverse to the equation you wrote in question 6. What do you notice? Okay, so we're going to find the inverse of f of x equals 4x. So the first step is replace f of x with y. And then step 2, switch x and y. So x equals 4y. And then step 3, we're going to solve for y. So we divide both sides by 4. So 1/4 x equals y. So y equals 1/4 x. And as an inverse, we write f inverse of x equals 1/4 x. All right, so go ahead and finish that up. All right, let's take a look at the next page. All right, activity 3.2, graphing inverse functions. In the previous activity, you wrote the inverse of a linear function using algebra. Let's consider how to show the inverse of a function using graph. All right, you can mark off the worked example, and let's take a look. Consider the graph of the function f of x equals 4x from the previous activity. Complete the steps in the worked example to graph the inverse. We're not going to use the patty paper. Okay. All right, so first thing, let's graph y equals x. So basically what you notice is y and x are the same numbers. So 0, 0, 200, 200, 400, 400, 600, 600, 800, 800. Okay. Now, to graph f of x, that's 4x. So that's this line right here. So we can use the point 0, 0, and it looks like 100, 400, and 200, 800. And let's go ahead and graph that in pink. So that's this line right here. Okay. Now for the inverse, let's do that in blue. All we have to do is switch the x and y values. So this becomes 0, 400, 800, and this becomes 0, 100, 200. All right, so let's graph those points. So 0, 0, 400, 100, 800, 200. Okay, go ahead and finish that up. All right. Compare the image you created and graph of the inverse. What do you notice about the image and the graph of the inverse? The image and the graph of the inverse are the same. What does this tell you about the graph of the function and the inverse about the line y equals x? The graph of the inverse of a function is a reflection of the function across the line y equals x. Okay, go and finish it up. All right, let's take a look at the next page. All right, teacher works through A, student works 3B and 3C. For each function and a given point in the graph of the function, determine the corresponding point in the graph of the inverse of the function. Given 3, 2 is a point on the graph g of x, what is the corresponding point on the graph of the inverse? The corresponding point on the graph of the inverse of g of x is 2, 3. That's all you have to do, is switch the x and y. All right, go ahead and work 3B and 3C on your own, and have a wonderful Wildcat day.